All right, so let's get going. We have to start from where we left yesterday, right? Let me go down. Okay, guys, so let's start with virtualization. So I think all of us know how compute virtualization has changed the compute, how compute resources are used, the complete paradigm, right, guys? You know that once there used to be like tower servers, standalone tower servers. Then there we used to have rack servers, then the blade servers. That has been the path how server technology evolved, right? From tower server to blade servers and thin blade servers with a lot of horsepower like UCS, and then it's a converge solution coming into picture with UCS, then hyper converge solutions, right? And all of them are like can be virtualized through different hypervisors. So hypervisor is something which which has been virtualizing servers to create multiple virtual machines inside one virtual physical server, right? If you Hyper-V can do that, is VMware vSphere can do that, Red Hat can do that, Oracle can do that, those kind of stuff. So then there is application virtualization, and then the network desktop PCs, the VDI and all, network virtualization, the VRFs, VDC, VRF, storage virtualization, where storage virtualization happens. I don't have much visibility in that, but yes, storage LUNs can be created inside one storage. You can have multiple LUN logical units and multiple. Of course, I have information on that. Sorry. Storage. One storage box. You can carve out multiple storage, small storage blocks, and give it to different clusters, present it to different clusters. Also, when you have Nutanix, where you have vSAN, virtual storage area network, and where here also in Nutanix you are doing storage virtualization, combining your storage piece together, right? Let's say do you have this server, this server, right? Just want to give a sneak peek to it so that you should know with when you are learning Nutanix, you should know storage piece for sure. And all you need a L2 switch to connect them, right? L3, even L3 will work, right? So L2, they should be in same VLAN, by the way. That's what they are doing, and some design. So all of them are connected. Let's say 20 gig port, right? And the boxes here are like host one, host two, like that. Just how storage virtualization has helped, right? Uh, Giving you background, like so this can have two more interfaces, right? That will be used for virtual machines, right? 4 gig, Now you have another switch. You can say data switch, where and it is integrated with wider network. This data switch for L2, L3 connectivity, for connectivity from outside, all that. And the switch upstream, and I'm giving you again high level because I will never connect my both the ports with single. Maybe I'll connect like this, guys, right? You know that. Maybe like this, one switch, two switch. So I'm removing it for simplicity. So it will be highly available, that I told you, as per design standard, right? So it's a storage switch, but storage dedicated switch, let me say that way. Now has got your, you know, storage, right? Every server. Nutanix is nothing but this, virtualizing the storage. Let's say 1 TB, 1 TB, 1 TB. Combined 4 TB is created, and different small LUNs are created out of it. So they are replicating between them. The CBM machine is created here. On each host will have a CBM, control VM, control VM, control VM, and they are replicating continuously. You know, they are using RAID, everything is working on this. You can put like n+1, n+2, n+3. You know, so if this goes down, this host itself goes down, all the data on it will be recovered up by these three. If you create, so you need some redundancy here just to maintain. That's a deep level Nutanix, by the way. But at a high level, you can understand the Nutanix is just nothing but virtualize, but combining physical storage that exists on each host into one virtualized storage, and presenting that combined virtualized storage to each ESXi host. Right. That's a storage virtualization. Also, even in the era of SAN, storage area network, we have storage boxes. We can still virtualize and divide same physical storage to different clusters, different appliances. We can make sure that the physical storage can be divided logically into multiple smaller storage, and then presented to ESXi host, or any physical server, whoever wanting to connect to wanting to have storage connectivity. All right, guys. Any questions or anything, please? You are welcome. This is fundamental to NSX, I would say. It's kind of underlay. Not necessarily storage or application server virtualization. Server virtualization is key to learning NSX. Also, network virtualization. We will, the virtualization I'm talking about here is basically the VMware vSphere based network virtualization. So once you understand that, we will move forward, start NSX. So it's important for you guys to understand network virtualization, compute virtualization at least, if not necessarily then the desktop virtualization or application virtualization or storage virtualization. Yeah. So who else has joined today? Okay. Vishal, and okay, got it. All right. So coming to this now, I'll jump to another one. So let's talk about server virtualization. You know, all of you, most of you may be knowing what is server virtualization. Here, I just want to give you a sneak peek. Server virtualization, single server and a single application, single operating system, single hardware. That used to be the case, right? Now with hypervisor, you can divide the same hardware. Hypervisor is now running between your virtual machines and hardware. So hypervisor will allocate resources, will manage the resources now. Resources that are there at the hardware level, your memory, your RAM, CPUs, those things. Compute resources, not storage one, right? So this hypervisor is going to manage them. So which means multiple virtual machines can be created, multiple systems can be created, and resources can be allocated to them. Let's say I have 24 core CPU total core. So I can have a hyper-threading, multiple, one core might be 2 vCPU and 24 core means 48 vCPU, and hyper-threading can give you more vCPU. So you can have maybe 60, 70, or maybe 100 virtual machines in a single ESXi host or in a single blade, right? So now what hypervisor do is a single physical server hardware. On top of that, your hypervisor is running and your hypervisor is then creating multiple virtual machines, the guest virtual machines. Inside each guest, you can have different operating system running: Linux, Oracle, best, Microsoft OS, Microsoft of what do you call that? Normal Microsoft of, you know, uh, Microsoft, the one running on here, running on my system, right? Yeah. So you can run all of that. Different operations: Linux, Unix, CentOS, all that. Yes, guys.
Also Acropolis.
Yeah, whatever you want to run, it's a standalone box. Yeah, that's the, yeah, correct. Yeah. Who just spoke?
Vishal.
Hi. Okay, yeah. All right. So server virtualization, right, guys?
Per, but in the like in this we are create on this physical server there is hypervisor, and on that one there are virtual machines. But earlier, like when hypervisor was not there, then I think server people used to create like virtual machines on physical server directly.
No, they never created anything like that. I don't remember. I don't read. I have not read anything like that, because the lot of compute resources
Uh-huh.
used to lie idle, you know, and you used to buy a complete hardware, and that hardware server used to run only just one application. You can maybe multiple application, but let's say you need Linux, you
No,
cannot run. Yeah, you can run just one operating system.
mean hypervisor was uh, since beginning when the servers like on physical server they need to create virtual machines. Hypervisor was there since beginning. Is it?
No, it was not there. It
Okay.
was not there. It was not there. It came later. Server hardware came first, and then
Mm-hmm.
later on, when industry realized that, uh, we used to call them tower servers. Servers like this, tower servers. We even,
Standalone servers
yeah,
means
standalone. Even at our home, you used to buy those tower type of machines, right?
right.
Yeah, even now we do that. The tower server, and this
Mm-hmm.
tower server, let's say you want to run Microsoft Office or something, let's say one operating system, nothing else. You do not have flexibility on the resources. You can, with hypervisor, you can have multiple virtual machines, two web
Mm-hmm.
servers, one SQL server, one database server, all right, one jump server, let's say, one test machine, whatever. You can have multiple with hypervisor, but without, if I remove hypervisor from here,
Uh-huh.
you are left with nothing,
Okay.
right?
Okay.
You are left with nothing. So let's say hypervisor, you just can create just one machine, that's it.
Okay.
All right. So with uh, with this server virtualization comes your what is wrong with my slide? Not sure. Anyway, so coming to okay, just give me a second. So I remember I used to put it up mm, like this. Anyway, so again, same thing. You have physical server A, physical server B, right? You have hypervisor running on both the physical servers on top of hardware, right? And the hypervisor is creating a lot of virtual machines for you. How do you create virtual machines? Everything I'll take you through. Just just think about it right now. That's it. All right. So let's move forward. And then with this, HA comes into picture, right? Sometimes high availability, and with the DRS capability in VMware vSphere, you get a lot of flexibility. You have VM2, VM3, and a VM1 running on this. Now VM1 has moved to physical server B. Why? Because of, it could be moved because of two reasons. One, that you do it manually. You say, okay, this server is less utilized. I'll I will load balance between both the hosts. My virtual machines will be load balanced between both the virtual machine, both the ESXi hosts. Right now, the second could be the DRS resource management system of VMware vSphere. What it does, it keeps track of all the ESXi hosts in the environment and sees and keeps tab on each ESXi host, and it takes a decision. If one of the ESXi hosts or two of the ESXi hosts, it observes that a highly utilized, the CPU RAM is highly utilized, it is going to migrate virtual machines from those highly utilized ESXi hosts to less utilized ESXi hosts. It is going to balance. It is going to balance across ESXi hosts so that all the ESXi hosts are optimally utilized. Yes, guys? And the performance is not impacted that way, right? The application performance, right? And any downtime that can that could be because of one of the ESXi hosts or some of the ESXi hosts getting highly utilized because of a number of reasons, right? You have applications running on those virtual machines, and the virtual machine, maybe a lot of people are trying to access like 9 a.m. in the morning. When people come to office, they try to open the application, right? Everybody is jumping, hundreds of people are trying to access that particular application, and the VM needs more resources, and it is consuming more resources in the ESXi host, and that the ESXi host might be already busy and with more demand for the resources. It will be highly utilized. Then DRS comes into picture and says, oh, I have another host, ESXi host, vacant, hardly being used. Why not move it? It dynamically moves the virtual machine to the other ESXi host. Yes. So far, any questions,
So,
guys?
so
Yeah.
in the from last slide 46 number. So
Yeah.
as you are saying that VM1 from virtual physical server A, we can directly move it to physical server B. Then like I'm not from server background. So how this is happening? Like if you want to move a virtual machine from one server to second one, how this will happen? Like in a very brief thing.
Mhm.
So vMotion will work here. Who was asking this question?
Vikrant.
So Vikrant, I'll give you example here. Shall I proceed in the?
Yeah, Pranay, who is
Yes,
this?
yes.
Yes, please go ahead.
Pranay.
Yes,
Yeah.
Pranay.
Pranati.
So
Yeah.
in there we have yeah, in this diagram, if you can see that we have two physical servers, physical server A and physical server B.
Uh-huh.
On top of that, we have hypervisor running,
Uh-huh.
and these two servers, these two physical servers, as a ESXi host in terms of virtual VMware, or in terms of Microsoft, that's Hyper-V, that will run in a single cluster.
Okay.
And we have HA enabled on those. We have HA, high availability option, enabled on
Got
that
it.
cluster. And in any case, in and vMotion works in a background. vMotion is a terminology which keeps the high availability, which migrate the virtual machine in case of any failover happen. If you want
Okay.
to do in, if you want to do a manual failover, let's suppose you are seeing that some load balancing, some resources are consuming more on a single server. So that DRS concept will come into place, and my vMotion will migrate that machine from one ESXi host to another ESXi host. So that's the concept on migrating the machine.
Okay. Simply they will like everything of VM1 application OS and everything will be moved through vMotion from one server to another one.
Yes,
Okay. Okay.
yes,
Eh,
complete virtual machine, which includes, if you'll see this green box where we have application and OS mentioned. So
Uh-huh.
that's a complete virtual machine with the OS, which this OS can be a Windows machine or Linux, anything. On top of that, one application is running. Let's take an example of SAP.
Okay.
Any anything happen, any failover happen, any resource utilization happen, then it will migrate complete virtual machine, this green box, VM2 or VM3, from physical server A to physical server B.
But Pranay,
Yeah.
in that case, like for example, this VM1 will have definitely have some IP address as well, right?
Okay, let me take it forward.
Yes.
Okay, give me
So
a
that
second.
IP,
Yeah, Pranay, I got you. Let me make a slide for everyone. Pranay is expert in it, I know, but let me explain in another way. I know there are some gaps. I wanted to cover it later. Maybe this is the right time, right? Let's guys, what is cluster, right? Let me take you back. Why cluster? Why we make cluster? What happens? That kind of stuff, right? So, what is vSphere? vSphere is a suite of components of protocols. If I can say systems, vCenter is one of them, right? And then the hyper vCenter is one component, one of the components of the hyper VMware vSphere suite, right? VMware vSphere protocol. Correct me if terms I am not using correctly, Pranay. I would need your help. I want to make sure they understand the concept of what is this VMware vSphere. And then you have hypervisor. Means on when you power it on this esxi host, you have to install esxi. Esxi on esxi is a hypervisor from VMware, and you on each host you are going to install that hypervisor. Means that you are going to bare metal servers. You have bare metal servers here, right? So you are going to install esxi
Okay.
6.5 or whatever is in the market, right? Either you boot it from SAN, right, or you directly install into it. When you install into it, what happens? You give it one IP address also. So vSwitch concept, I was about to come into that. So I'll come to that. I mean, let's high level. Let me give you high level here. So the component is one hypervisor and the vCenter, right? vCenter is the management plane.
Okay.
Management plane for clusters. So these hosts will be placed in single clusters. Let's say switch, and they will connect to a switch also. Switch. I'm putting just one connection, and the network configuration should be consistent all across. Between the lines, if 10 VLANs are allowed, same number of VLANs should be allowed everywhere, right?
Right.
And let's say your virtual machine, your system, this VM is sitting here in VLAN 10.
Okay.
It goes here tomorrow. I move it here, right? Where do I move it from? vCenter does it, right? I'll come to that. So when you move this trunk actually has
VLAN 10 allowed.
VLAN 10 allowed. This is also having this the consistent configuration there. There should not be any
Okay.
problem,
Okay.
right?
So you need to have a layer 2 path.
Yeah.
Which is the most.
Yeah. So layer 3 is also possible, very much possible these days. Even layer 3 is possible. Yeah, earlier they used to say layer 2, layer 3 is possible now. So now when this machine comes here, it is also retaining MAC address. And it is just as gratuitous ARP or something happening. It is, the moment it comes here, the MAC address will be bound to this for networking people. From here to here, basic networking concept. It will come to this. Right?
Okay.
Just a single ping drop happens during this all transition. You ping from outside, the machine comes here, just single where is machine? Single ping drop, right? Just
Right.
that's what I have seen. So VLAN 10. Now what this VLAN 10 needs some connectivity also, right?
Right.
Which when you install esxi host, right? Esxi in a host, you are by default there is one vSwitch created.
In
One
this
vSwitch.
server only.
No, in the hypervisor.
Okay.
One vSwitch created, and also one management interface you give it when you install this, right?
Right.
Multiple vSwitches are possible, and this vSwitch, let me delete it first, right? Completely. I want to come to vSwitch now. So let me, on high level, I'll come to that. I have
Okay.
slides on that particular one, so I just do not want to jump. So basically, what Pranay is saying is that the DRS, you make cluster because you
Mhm.
want to have high availability. So that one
Okay.
system going down, the other one ESXi host going down, the other ESXi host can take care of the workloads that the now down machine used to have. You know,
And what is DRS full form? Like disaster recovery system or something else?
DRS, dynamic
It's
resource.
distributed research scheduler.
Okay, sorry. This
Repeat.
Distributed research scheduler.
distributed
Distributed
resource.
resource scheduler. Okay.
So here, guys, what we need to understand, I'll come to that why cluster needed. vCenter is a management plane. All the ESXi, how you configure, I'll come to that, right?
Okay. Okay.
Yeah,
Okay.
just hold on. Even if it is not covered in slides, I'll see. It must be covered. It's a high level I'm giving you. I'll come slowly. Now virtualization, how it is going to help us? This is what it is given. Shut down for maintenance. One of the ESXi host is shut down for maintenance, and all the virtual machines from that will be migrated to another ESXi host in the cluster. From the vCenter, you make clusters, right? You tell each ESXi host you are part of cluster, right? So these are part of cluster. So when they are part of cluster, if it goes down, the HA kicks in. Automatically, all the virtual machines will come up on another host, right? Or you before maintenance, you can demotion them. All of a sudden, it's due to power down. Even in that case, VMware vSphere HA will kick in, and the virtual machines that were there will come up on the other host, right? That's how it happens. Pranay, please jump in wherever I'm not right. Right, you are expert in it. So from storage, they make sure that the virtual machines are coming up on the other ESXi host. All of a sudden, power might go down, right? Something might happen here. In power plant, you are manually doing demotion and putting everything that is on this host here on where my mouse is will be moved to another host, and that way it's a manual. But there is a possibility that the host might lose power or might malfunction or something. In that case, of course, the virtual machines will automatically come live on another ESXi host of the cluster.
I
So
have a question.
yeah,
So
yes,
let's say our physical server A is down and
yeah,
we have moved all the VMs to another physical server B.
yeah,
Now every VM would be having a MAC address and an IP address. Let's say, for example, we use VLAN 10. Uh, One of the VM1 IP 192.168.1.1, right, which is associated to that MAC address, which is in physical server A. Now physical server is down, or or any maintenance is going on, so we are moving that VM to another physical server. So that VM would be having the same MAC address. How about the IP address? Will it retain the IP address as well?
yes.
And how's it?
It will retain IP address,
Same IP address would be
same
going.
IP address, same MAC address.
Okay.
Okay, so let's move forward. Hypervisor virtualization. These are the hypervisors: VMware, Citrix, Oracle, Microsoft, Red Hat, and many more. Right. And now I'm coming to this. I will open a slide here. I'll start again. So before coming to this one, let me do one thing. Now, Vishal, you will get more clarity now. All IP, everything. This is crux of understanding, virtualization, I would say. Uh, so let's say what do you do? First, you need to put 4 hosts in a cluster, let's say, right? And on each cluster, each host, you put ESXi host, hypervisor layer, right? You put hyper when you are installing hypervisor on a host, During installation of vswitch is gets created. What is vswitch? As I said, I'm giving you a high level first of all, to start with. Vswitch, as I said, like with hypervisor, you can create multiple virtual machines in an ESXi host. Those virtual machines need connectivity also, right? I cannot connect directly, to physical switches. So the virtual machines that are here that we are creating, they need connectivity, right? For that connectivity, virtual switches are required. Maybe yellow, yellow machine, blue machine, whatever, right? Green machine. So when you install ESXi host, ESXi on a host, this hypervisor creates a vSwitch for you, because it has to be there for two counts. Number one, this ESXi host should be reachable from outside once a ESXi host is connected, so that you can remotely connect it. Let's say, listen carefully, guys, very carefully. Now you have this switch here, and this is physical switch. This is trunk. This is trunk. Let's say trunk VLAN 10, 20, 30. Right. 20, 30. 10, 20, 30. So when you are installing this hypervisor, ESXi hypervisor on it, it creates a one vSwitch and maps one of the uplinks to the vSwitch. One of the uplinks, first uplink, let's say this one. And this port is called VMNIC. Automatically it maps this VMNIC 0, let's say. Because now once it's installed, you have, so it automatically maps only one of the uplink. It may have a number of, for example, I have two uplinks right now. So this pnic is mapped to VMNIC. This is pnic 1, let's say pnic 1. And in VSPF reads it as VMNIC in its language, right? pnic 2. So this, when you install this ESXi in the host, it creates a vSwitch for you, and vSwitch is just to facilitate communication for virtual machines that you will create in this host, also for management connectivity from to this host from outside, right? I'll come to that. I have not yet created these things, so I'm putting them out. Yeah, go ahead. I'm just installing ESXi right now.
Yes, sir.
Yeah.
Okay. So in the meanwhile, I have one question. Here.
Go
You
ahead.
mentioned trunking of VLAN 10, 20, and you mentioned that trunking of VLAN 10, 20, and 30 or
Yeah.
on PNIC link, right?
Yeah.
So at the network background, do we need to trunk this for particular ESXi host, or that happens on a switch basis? How it works?
It happens for all ESXi hosts from the switch.
Okay, means any ESXi host we add, the network team has to do trunking, right?
Of course, yes. As I said, I'll come to that. So trunking, I'll come to that. Not even doing trunking at the moment, let's say. Okay, you will understand that. Okay, so
Okay.
so your question is a bit dicey at the moment from you. So I know the stuff, but You'll understand it. So initially this vmnic 0 will be created, and the vswitch. Also, when you are creating, you give a management IP address also. It's a kernel interface. You provide IP address also the VLAN number. Okay. So this management IP address is nothing but it will be part of some VLAN 10, let's say. Right? Because you have planned which VLAN is going to be my management VLAN, which VLAN going to be my workload VLAN, what VLAN going to be vMotion VLAN, right? This management interface, right? So by default, when you know what you do is that whenever you are um, installing hypervisor, which is esxi in our case, it will create a vswitch, and this vswitch will be assigned one of the uplinks, physical uplinks. Virtually it will connect like that, not two of them, but later on you have to do. And then this you will also give it a one IP address and the VLAN number you can give. It could be part of a VLAN number or default VLAN also sometimes. In that case also, you can still reach it, but we don't do this. We make it part of standard VLAN, user-defined VLAN, right? And this becomes a VLAN part 10, which means once it is part of VLAN 10, you can reach this ESXi host from outside. So hypervisor, it is to connect to hypervisor, this interface, the kernel interface, type management, right? Kernel interface means it's a system interface. You can manage system resources, everything from here, right? So guys, what happens is once that is done, this system resource management interface will be, let me put it like this. You can ping it, you can if you have HTTP enabled, you can CLI it, SSH if SSH is enabled, right? And now you have a vCenter here. You can reach to it from vCenter also, because vCenter is management plane for all this, right? So this vCenter, what you do in vCenter is you make sure that this vCenter, similarly there will be multiple servers. So in the vCenter, I'll show you vCenter console, don't worry. And in this vCenter, you add this host under the cluster. You make, from here the clustering, everything happens from here. You make part of one cluster, you say cluster name, and you add under that cluster whatever, 1 2 3 4 5 6 host. Now this vCenter can see this. Now entire ESXi host can be managed from vCenter. Yes guys, you can create virtual machines, you can create port groups, whatever you want to do. Let's say now you want to create now second thing you will do, you will also add this to this, or make it, let me do this way, right? vmnic 1. So once from the vCenter you add another one in it, right? And also what you do, you make it part of VDS. Now I'll come to that VDS in a while. So think about vSwitch at the moment, right? So what happens is, now you have, by default from the vSwitch you have access to, from the vCenter you have access to the ESXi host. By default it has just one vSwitch 0 they call it by default. And then the vmnic and another host, another vSwitch, you connect another vmnic, and this is how the connectivity is. This is the vCenter, this is vCenter, and under vCenter you have cluster, let's say Linux cluster or Windows cluster. Right? You can configure the clustering, everything happens from window cluster, from vCenter. Now, under the cluster, you add host. There is option add host under the cluster. Whichever host you add, they become part of that cluster, right? I added this host, maybe another host I can add, right? Maybe it has, let me put different color, maybe this color. You add another host, so it will become a cluster of 3 hosts now from the vCenter. And on each ESXi host, you do the you install the hypervisor. You give management IP, because we have already provisioned management IP, DNS, everything. When when ESXi host is getting installed, then at that time you give management IP address, right? Once the management IP address is there, this ESXi host is reachable from outside, and which means it is reachable from the vCenter also. And you go to vCenter, and on the vCenter you make a cluster and add ESXi host under that cluster, right? Let's say window cluster, right? Now you from here you say I want to create. So storage is also exposed to it, by the way. I'll come to that. So it has a storage connectivity also. The storage is exposed to it. So let's focus on networking piece of it. Even you don't need to install the hypervisor also from NSX point of view. Compute people are good in it. They have been doing it. Let them do that piece. Even in my case also, but you should know each bit of vSwitch, BDS, VMNIC, everything you should know. Very important now. You cannot leave everything to compute, because it will be very difficult for you to troubleshoot without knowing these things. So now,
but in a single like ESX I host or physical this hypervisor, there is only one vSwitch, or there can be many vSwitches?
many vSwitches. Maybe there is 500, 200. I don't know. I will come to that. Okay. So Pranay, I need your help. So far what we have, I am teaching to my colleagues. Is that correct? Pranay?
Yes, it's correct.
Okay. Okay. So Pranay is preparing for DCV, data center virtualization. He is working with IBM right now, and very good at technology. So I happen to know him from Bhima community. So yeah, please, Vishal, go ahead.
Now, as you said, we have let's say a host, and we have installed a hypervisor ESXi, and now vSwitch is created by default, right?
Yep.
And by default, you mean to say vNIC 0 would be mapped to a physical NIC.
One of the physical NICs, yes.
Only one of the
Yeah.
initially.
Initially, yeah.
So, and later on, we can put on multiple connections with the physical switch from the
Yes.
vSwitch.
From the vCenter, yes.
So, initially, when you configure it, only one is mapped by default.
Yes.
Okay.
And only one vSwitch will be there, and the kernel interface will be on the vSwitch 0 only.
Right. So now, if we are creating multiple vSwitches, we have to create the kernel on all of them.
Yes. But you don't need multiple vSwitches in a single until you have a design. That's where the design comes into picture. Whether you need 2 vSwitch, 3 vSwitch,
So let's say we have 3 vSwitch, so we would be requiring the kernel interface on all 3 vSwitches.
No. That is not required. Only one vSwitch. Entire ESXi host can be managed. Only one vSwitch. Let's say you have another vSwitch, right? Kernel interface is not required there. Not vMotion interface. Nothing required. Only the port group that will connect to machines will be required.
So in my understanding, the kernel ports are required for certain purpose, which includes your storage traffic, your management, your view motion. So if you require those kind of features, then you need to have a kernel, otherwise just remove it.
Yeah, you are right. So if you have vMotion interface it is applicable to ESXi level. Management interface is applicable to ESXi. You have You can have multiple management interfaces, by the way. I think, Pranay, you can have management interface, multiple management interfaces, right? Because
Yes. That we can have multiple interface, management interface for different purpose.
yes,
So we have many features which use vkernel port, and for those all features such as vmotion, storage replication, and other things, we can use different management ports or a single port also.
yeah,
But
No,
for the
so
best practices, we
Pranay,
always follow that.
yeah. Please continue.
Yeah,
yeah,
go ahead.
my question is, let's say for by default one vSwitch is created which is mapped to physical
No,
switch
Vishal,
by
Vishal, Vishal.
one.
I'll explain you. Just let him complete. I know what you are asking. I'll answer
Actually,
the
his
question.
voice is breaking.
My voice is breaking. Hello.
Yes,
No, not for me.
I don't know.
Pranay's voice.
Oh yeah, Pranay's voice. So Pranay, continue. I'll pick that up. I know what you are saying. Just taking another thought. I'll come to you, Vishal. Just a minute. So Pranay, please continue. You just said that we can have multiple management interfaces. Management interface, special type of interfaces, kernel interfaces that we can use for emotion. We can use
Yeah.
for storage. We can use for management. But my question is, some time back I used to have do used to create two management interfaces, one for vCenter connectivity, one for I used to give to client directly. So I had exposed I created two management interfaces actually, and not for the vmotion type, not for the storage type, yeah, esxi type stuff. I created management interface and exposed that particular management interface only to client. Is that possible to have different management interfaces? You there?
So in the is it you're talking about the management mode of esxi host, right?
Yeah, yeah. Only management. Yeah.
Yeah. So in that scenario, what happened that if a management port required for multiple purpose, as I said, that for vmotion we require for what we follow in a scenario for best practices is that vmotion we always keep a different management port. For replication of storage, we keep a different management port. So these all management port can run on a single vSwitch, and these all vSwitch, which is if you'll see here in the diagram, vSwitch 0 and running with a vnic 0 and vnic 1, uh, that's two physical NIC coming here. So if we have physical NIC, we have two physical NIC on a esxi host, we can have maximum two virtual switches,
Yeah,
and in
got it.
single virtual switch we can
Yeah,
have multiple ports.
got it, Pranay. Thanks a
Yeah.
lot. So basically, Vishal, what your question is, this management interface. Now we can, when we create, these are special kind of interfaces. These could be vMotion interface, storage replication interface, and the management interface. Now, this management interface could reside in different vSwitch also, on the same vSwitch also, but provided, let's say I create another vSwitch, but you have to give uplink also, right? And which means you have just two physical interfaces, and you cannot have more than two vSwitches because you have to give uplink also, right? And this management interface will manage entire esxi host. You don't need to have management here. No, you are not required. You don't need vMotion interface here. If you have vMotion here, vMotion interface here, right, in VLAN 20, let's say, vMotion, vMotion 20 interface, 20 VLAN 20, management VLAN 10. You don't need on VSwitch 1 anymore. But what you need to give uplink also. Otherwise, it will not be able to talk to outside world, right? So your vSwitch will be limited to number of uplinks you have.
Okay, that is fine. So what I got it for each vSwitch we should have at least one uplink. If we are having two uplinks, so we can create two. If we are three, we can create three. So let's say vswitch 0 is having yellow machines and vswitch 1 is having green machine. The purpose of yellow machines are different and the purpose of the green machines are different totally. So for that I require I mean then also the management, the kernel part, everything, the other stuff would be done by a vswitch 0, or
vswitch 0. It doesn't matter. Yeah.
so there is no use of vswitch 1 then.
vswitch 1 you can have virtual machine here running Linux OS. Why not? Right?
No, so the purpose of green machine is different, so I would require I mean specific I don't know now in server world what are the different. So is there any scenario which you have created, either you or Pranay?
No, there will be multiple scenarios, Vishal. That's a design question, right? The concept is there will be multiple scenarios. No doubt about this. There could be n number of scenarios where you have multiple view switches, multiple DBS, and all that stuff, right? But you have to look at whether you need that kind of thing or not. Once you know fundamentals, design will be left to you after you know the technology. Let's not go that far with scenarios and all. First, understand the view switch concept, right? You can have multiple view switches, and you can create. You see, Linux here, MS OS here, Microsoft OS here, right? The virtual machine. Still, they will be able to talk to outside world. And to manage the entire esxi host, you have this management interface. You have the vMotion. This virtual machine will use the same vMotion interface. They are kernel level interfaces actually. You know.
Okay.
In the
And
one more point, like question, like if you are having two physical NIC, pnic 1, pnic 2, from physical server to physical switch,
yeah,
and from virtual switch you will have only one vnic virtual NIC from vnic 0 to pnic 1. So don't we require like another physical this mapping as well from with this vswitch? Because in this case, if like this physical NIC goes down and we are having a mapping with vnic vmnic 0 with pnic 1, so it will go down, then there will be no connectivity from this v switch towards this physical switch.
if you have if you have this kind of scenario, right?
Uh-huh.
If you have this kind of scenario, you have two links, right?
Yeah,
And
that's what I'm asking.
this if been up now, you have this scenario,
Okay.
unique one. Now you can do aggregate them. You have option. You can do like P supported on the devices. Let's say like P. You can create port channel between them, right?
Okay.
That's one option.
Mhm.
Second option, you can make them active
Okay.
based on the MAC address of the source virtual machine, source ID of the virtual machine. So in that case, it will load balance. Some virtual machines will pick this. Some virtual machines will pick this. If this goes down, the virtual machine will pick this. So
Okay.
active port channel is possible depending on
Okay.
your design. Okay.
Thanks.
So Pranay, I have a question by the way. On the management interfaces and the vMotion interfaces, are they created on the vSwitch or they are kernel interfaces created outside? Because I seem to forgot or outside of the this.
No, the earlier was the correct concept. Yes.
Which one?
Yeah.
This one, right?
No, the keep. Yes, that's correct. So this is the concept.
Okay, yeah. Thank you. So I wanted to double check because once vMotion means it will be applicable across switches. Entire is this Linux server being vMotion using this interface on another host, right?
Uh,
And
uh,
yeah,
so basically, I wanted to understand it is going to, if there is a traffic for management or for vMotion or for whatever, the especially the kernel interface I'm talking about.
these are kernel interfaces only.
Yeah.
vMotion management. Yeah.
So these kernel interface, even I'm also missing out. I don't remember. It's long time I have read about the VCP. So is it going to take the path of the VMNIC, or it is going to have a separate path of its own to the
So
physical switch?
yeah, it depends. It depends, right? Let's say this vSwitch you have dedicated only for management and vMotion. Let's say by design, and you have four links. Let's say uplink. I got your question, right? You have two more uplinks, right? Normally in design, what we do,
Actually, I have forgot that concept
yeah,
all.
that's fine, yeah. So here, you know, you have another physical switch, right? And what you do, this physical switch, this is, oh God, second. This will be mapped to, if I can, let me do one thing, guys, 1 second, right? Let me make it smaller, not necessary, it should be big, right? So I have 4 uplinks, right? And 2 uplinks will be for the virtual machines, right? PNIC 3, PNIC 4, right? And my virtual, all the machines I'll connect to vSwitch 1, all the machines, right? Means they will take this path, and anything, any replication management will happen through this different vSwitches. Or if you do, or you can share also, right? It is no bar. You can still have this machine, is this Linux or Unix or CentOS or anything can connect to this, but there is no one stopping you creating multiple machines here connecting through this. If they are connecting to this vSwitch 0, they will use the uplink that are connected to vSwitch 0, right? The traffic go out for vMotion. Let's say vMotion happens for this Linux now, right? It will use this interface, uplink interface for vMotion. But if you want to ping Linux, then this interface will be used. You want to get to this Linux, some application running, users are trying to connect, they will use this path. But
No,
yeah,
so Indra, I'm just a little bit confused now. That you are saying that the Linux, which is on the vSwitch 1, if
yeah,
it wants to do the vMotion, it will do it via the vSwitch 0. Do you think is it possible?
yeah, it will it will use this path. This is what it is. Okay. So it's an internal mechanism. It's a Linux server for vMotion. It will use vSwitch vMotion interface, this interface and this path and this switch. But if you want to for any data purpose, user traffic, application traffic, anything, right? It will use this switch. Yes, it is. This is how it happens.
Okay, so your Linux is connected to these both these switches, vSwitch
No, no,
0
no,
and vSwitch 1.
don't think like that. They are not. It is connected to vSwitch only, right? This vMotion interface is the kernel interface, and
Yes.
internally Linux server will use this vMotion interface for vMotioning. If you are want to move this system to another host, it will use this interface to get
No,
out of the esxi host.
no, that is okay, Indra. So Indra, what I'm trying to say, is it a standard switch or it's a distributed switch? You tell me
Right,
first of all.
right now it's a standard, I'm talking about standard switch, but inside each esxi host working is like that only.
Okay, so
Inside,
you mean to say that even though my application is not connected to that particular vSwitch, but the vMotion will happen via some other switch
yeah,
if
via
it
the,
is designed in that way.
yes, if it is designed that way, yes, you got it. It will happen through vSwitch 1, vSwitch 0, but it is connected to vSwitch 1 for data connectivity, whatever, for patching, for
But we are not doing the mapping of the vSwitch and the Linux in this case.
this is how the hypervisor works, man. You have to understand that. If you want to go deeper, how it is internally communicating with this vMotion is system interface in a way.
Yeah, kernel, that I know. Yes.
Yeah, this is system interface. So internally, the hypervisor is making sure this Linux, the data being transferred to another host, vMotion data through this interface.
Okay. And also one more thing. So when there is a kernel interface on this. Okay. So end of the day, whatever kernel traffic is, so it is going to take the same path of this VM NIC, and then it goes to the physical switch.
Yes, yes.
We don't need to have a
Any
dedicated.
system traffic, any management traffic, any vMotion traffic.
Yeah. So end of the day, it is taking the same VM NIC 0, then PNIC 1, then going to the physical switch.
Yep. for vMotion only. Remember, for it only for
Then,
vMotion.
then I remember that there's I was just recall that why it is being advised to carry the management traffic on the kernel because it doesn't goes down, something like that. I have read long back.
Kernel this is how the hyperbadger has been designed, and it is always going to use the system interfaces, the special interfaces, which is vMotion interface for vMotion. But in design, you can allocate dedicated interfaces, like I have done dedicated interface for vMotion.
So we can also have a dedicated interface for my kernel also.
Yeah. This will be mapped automatically, right? I'm not using for anything else. Now you see in the vSwitch you have nothing, just a vMotion interface, which means you are not sharing the uplinks with anyone else, because you have only two interfaces, one for management, one for only two type of traffic will be used by will be traversing through these uplinks, yellow and red, right?
Yeah.
That's a design decision, or you can share them with multiple. No one can stop you. But by design, in my design, I have not done that. I have
So
created.
Abhay,
Yeah.
what I think is, let's say we have a corporate network, physical switch. We have using two physical NICs connected to a virtual switch, right? And if we are having two physical NIC, we can also have two virtual switches. For let's say example, if we are hosting web traffic on a particular host, and we have web servers as well, SQL servers, so that another switch, virtual switch, can be act as an isolated network, like only web proxies can, I mean web server can talk to the SQL database and DB, like that. That scenario can be happened in this, if
So
we are
that is
using.
again, so that is something which is fully based on the design, how exactly your
Right,
requirement is.
now I got the point here. We can have I mean as per what Indra stated, uh, one physical switch will have by default one V switch. If we are using two physical switches, we can have two V switches. That would depend upon the design, how we are creating, like,
Yes, it is fully based on the design. We can
design.
connect the single V switch with both the physical switches as well as with different V switches. So it's all depends how exactly
Right.
we need that.
Yeah.
All right, guys. So let me ask Jivendra, is this concept clear to you?
So I have a question here.
Yeah, I'm coming to you also. Just give me a second. Jivendra, this concept clear to you?
But indirectly, I am in BCC, so whatever you are teaching, that's fine. Yeah, I know this.
Oh, very nice. Now, I'm coming one by one. I want to make sure everybody understands this. Abhay and Vishal are good. Jivendra is good. And Amit, is this okay with you? You understood
I
this?
I have a question here.
Okay, Amit, yeah.
I was asking. So my question is, if we have a two PNIC and we have we switch 0 and we want to have two more switch, we switch 1 and 2.
Yeah.
So how they will, associated with the PNIC 1 and 2? I mean, they will directly associated with the PNIC 1 and 2, or they will go via we switch 0.
You see, when you install esxi host, you are the esxi host is coming up with just one vSwitch, right?
Yes, correct,
And when you need more vSwitches, you are going to create more vSwitches from
correct.
from the vCenter, and depending on how many uplinks you have on that particular host, you can assign, right? If you have four uplinks and you are going to create one more vSwitch, you can give the two uplinks to vSwitch 0. By the way, vSwitch 0 will be there with one uplink by default. You can assign one more for high availability. Then you are creating one more vSwitch, and this particular vSwitch, you need to assign manually the uplinks that are available on that particular host. It is not going to happen by default by itself.
So see, I'm not saying it is by default. So see, if the PNIC 1 and 2 will be bind with the vSwitch 0, so could we bind vSwitch 1 and 2 with PNIC 1 and 2?
Yes.
Okay.
If traffic has to move from here to here, let's say you are saying v switch 0 and v switch 1 should communicate with each other, right? This is what you're saying.
No, no, no. I'm saying the I mean for the data part we will use vswitch 1 and 2 for the data, right? So the data traffic will go via vswitch 0 or will directly go to PNIC 1 and 2. I mean the binding with the PNIC 1 and 2 uh, will happen to vswitch 1 and 2.
If I understood you correctly, Amit, see, you have v switch 1 here, right? As I said, these are mapped like this, right? Traffic from Linux machine will hit v switch 1 or will pick either PNIC 1 or PNIC 4, depending on the whether it's a lag
I,
P or
I
lag P.
understand this concept, but my question is we don't have PNIC 3 and 4. We have only two PNIC 1 and 2.
Which
And
means your v switch does not exist. Let's say if it exists, then you have to assign it one PNIC, right? And you are connecting your machine here. That way you are using one of the PNICs, right?
so see, we have in this case we only have two PNIC 1 and 2, and we have the multiple V switches. I mean
You
V switch
cannot have
2.
more than two v switches. First of all, you
So,
cannot have more than two v switches.
so
Every v
Inder, I just wanted to come in. Basically, why Amit is a bit confused because when I asked the question on the V motion where you said that it will internally the switch 1 will communicate with v switch 0 to go to the destination for the kernel traffic. So what he is expecting that if suppose if I don't have the uplink from the v switch 2 towards the physical switch, so will it take the path of the v switch 0 towards the physical switch? Is it possible?
I mean, the theory itself is wrong, right? If your v switch is not having uplink, so it's of no use. Let's
Correct.
not
No,
go
it is
that direction.
no. It is possible.
No, that
Uh,
you do in your labs, right? That's not a
no,
discussion.
no, no, no.
If it,
Let's say if we have,
Vishal, 1 second,
hold on.
1 second, Vishal, 1 second. If you have V switch here, if you do not have uplink, then that's not the question because this is of no use.
See, this is what my question is. Could we bind the multiple V switches with PNIC 1 or 2?
No. Only one V switch maps to one PNIC.
Okay,
You
okay.
cannot overlap them.
Okay. This was my
Now,
question.
yeah, okay. Now Vishal, your question.
Only one PNIC can be mapped to a virtual switch. That is wrong. Multiple PNIC can be matched to a particular V switch. Let's say we have V switch 0, we can bind both PNIC 1 and PNIC 2 to this switch. And
Yeah.
if we are having another virtual switch, we can bind that virtual switch to a virtual switch 0 with another VNIC.
No.
So that
Vishal,
is possible.
Vishal, see what Amit is saying is different from what you are saying, right? Amit is saying whether I can bind this PNIC 1 to more than one V switches. I said no, and that is true, right? You agree?
Yes, that I agree on that.
And yeah, so you also said if I have two PNICs, can I bind them to two V switches? Yes, as many uplinks you have available, you can bind number of uplinks, whatever number of uplinks you have available to any V switch. Maybe you have 20 physical uplinks. You can bind all 20 with one V switch, depending on your design requirement. Minimum there should be one, and one you cannot share one uplink with more than one switches. It is dedicated one to one mapping, right?
Come again on the last part,
It is
please.
it's a one to one mapping. One PNIC
So
will be given to one V switch only. It cannot be given, that same physical PNIC cannot be given to another V switch.
see, if I remember, we can do that. Uh,
Oh no,
We have to
see,
check out about
Vishal, that's
it.
not
If I
possible. Yeah, logic wise also, na.
just a second, guys. The person who is expert, he's sitting idle. Who's Pranay? He should answer that because this is the area where we have not been worked or extensively. Okay,
No,
and
that. Yeah, that's a simple. I'm
Yeah. And
wherever.
Vishal, I believe you are saying that there is a gap in the understanding. What Inder is saying that PNIC 1 could only be associated to single V switch, and maybe what you are saying that a single PNIC could be associated to two different V switches. This is what you
No,
are
no,
saying.
no, no. No,
Say
I'm
yes.
saying is no. I'm saying is if we have two PNICs,
Hmm.
it can be associated to single. Let's say V switch 0. Both the PNIC
Yes.
can be associated.
Yes. That Inder is also saying yes for that. Obviously, you should. You can do that. At the same time, PNIC 1 could go to switch 0 and PNIC 2 could go to switch 1. That is also possible. That is a
That
one-to-one
is also
binding,
possible.
right?
Right. That
So,
is also possible.
yes. So, Inder is also saying the same thing. So, there is a confusion while talking, maybe.
Yeah, yeah, yeah. So the question from Amit was whether we can bind one PNIC to different switches. That was question from him. So I said no. All right. So good. So
And
Amit,
Inder, one more thing. So, will you be taking us through the a kind of a packet flow that how the traffic is generating from the Linux box and maybe the Linux VM, and how it is taking the path to the physical switches? Maybe.
yeah, yeah. In an SX classes, I'm going to do that.
Okay. Okay. No
It's
problem.
fundamental.
Yeah.
So coming to who is left. So let me come to individuals. I want to make sure everybody is on same page. So by Amit, Amit, you are good now. Any questions?
No, so far so good.
Javendra is good. And Pranay, you know it already, but from the physical side also you are aware of this, right? Oh,
Yes, Inder. Got
okay.
this.
Yeah, on the physical side, I was a bit worried because we need to trunk them. Whichever VLAN we put our vMotion or system interfaces on, we need to allow them on the trunk so that the
Yeah.
communication can happen. All right.
I
And
have
in
one
there,
question. Yeah.
in there, one more thing I wanted to add over here. That if it is possible, if we can also discuss, it is good for the community also. That what are the different scenarios, maybe the real time scenarios where we go for active, where we go for active standby, where we do Mac pinning. So those kind of scenarios, if we can discuss, maybe not today, maybe later on, as per your convenience, that is really going to help the whole forum here.
Yeah, yeah. I have a
I
design course.
agree. I agree with Amit.
I have a design course for that. During design, we are going to discuss everything. So
Yeah,
I'm
that
going
is
to.
okay.
Yeah.
Okay, fine, fine.
Yes, Pranay, you had a question.
So, Inder, I had a question, but I'm not sure if it's relevant to this session. When we face some kind of issue, when virtual machines are not reachable, in any case, we reach out to network team, and they sometimes they come with a conclusion that they have mapped the port channel at the back end. So, can you give me a two line, any small information like how you do this on a back end?
Sure, man. Let me create one. All the scenarios for you.
Yeah.
Yeah, that's a takeaway from for you because rest of us are maybe network people will take away other things. One sec.
Okay.
For you, you know already the emotion stuff, everything. I will give me 10 minutes. I want to make sure that he is done with this part. Normally, we let's talk about legacy network. What happens is that you have top of the rack switches and then you have the L3 switches here, L2, L3 boundary we call it, right? These are L2, L3 boundary. Normally, so there could be one scenario like this. These days, everybody, who is not going HDM, this kind of scenarios are everywhere. This in the top of the rack switch one, where actually the physically your system is connecting, your server is connecting. This is top of the rack, right? Switch 2, and this is L2 L3 boundary instead of kind of L3 device, L3 switch. You may for simplicity I'm putting L3 switch, right? So normally what people do, there could be two scenario. One this way, this is port channel, right? uh, in a way it's the same thing by the way. So people do this way,
These
and
are these are a three-tier architecture or maybe two-tier architecture, something like that.
it's a collapsed backbone, you can say a two tier only. Yeah.
Okay.
So I'm just, for simplicity, I'm putting it for Pranay's point of view. What network people do on their side, right? That's it. Anyway, so these are logically connected. Uh, so Pranay, I'll have a class with you maybe this week sometime or 2 hour. Then I'll explain. These are port channel. Binding of links called port channel. Binding of links is called port channel. And let's say your host is connected here, big host, and you have a vSwitch here, and this vSwitch, let's say yellow, and this vSwitch is the management interface. Let's say uh, let's say our servers are on VLAN 10, 20, 30, 40, 50, right? So here you have the virtual machines connected. No. So these virtual machines are connected. They are, let's say, on different VLANs, VLAN 30, 40, 50, and whatever, right? This is how you do. You connect with the VC, that you understand. I know it. So right now, these are in VLAN 10, 20, 30. For others also, it's a good guys. So a complete flow. This is kind of complete flow, but we will discuss in design scenarios also. So this is your vSwitch, right? Now you have two uplinks going here, right? This could be trunk or port channel depending on the discussion with compute team. They say it's a port channel also possible, like P, right? Binding of these ports. So these VLANs should be allowed here on all the links on the port channel, right? Here, here in legacy one, all the here. That is the only thing they do. They allow the trunk or L3 interface, because the default gateway from them is .1, right? Whatever subnet they are, default gateway is here on the L3 which is configured. Which HSRP they run, HSRP or VRRP depending on the device. Let's say VLAN 10. I'll take one example. VLAN 10 L3 interface will be on the L3 switch. VLAN 10 equivalent to subnet, right? Equivalent to one default gateway on this. Let's say VLAN 10 has IP 10.10.10.1. That will be default gateway configured on L3 switch number 1. Right? And default gateway, then it has a physical IP also. That's called HSRP, by the way. Let's say physical IP.2, right? And physical IP.3 here. What else we do is that this is virtual IP, and this is applicable for both of them. Can reply virtual IP. So your default gateway on this host will be virtual IP here. Now what happens is your traffic is hitting vSwitch. From here it is going to top of the rack switch, one of the type of the rack switch. It can go only when these ports are configured for the VLAN 10, 20, 30, right? In this case, for example, this virtual machine wanting to talk to outside world, what it is going to do is it is going to hit the default gateway first, right? For that, this interface that you are seeing should have VLAN 10 allowed. Similarly, this interface, uplink interfaces, so they have to allow everywhere. Also the proper L3 gateway configured here, and then they advertise this subnet into routing protocol so that it can go outside of data center. Let's say this is, they need to advertise everything from here like that. This is wider world, right? Let's say wider network outside data center. So this subnet now goes here, and if somebody sitting in the branch office also gets that route, right? User, and that guy connects to this network and then can get to this virtual machine. So basically what they do at data center level, they create VLAN on top of the rack switch on VLAN database, top of the rack switch VLAN database, also allow on the downlink which are facing your host, also allow on the uplinks which are facing L3 interfaces where your default gateway is. Similarly, on the both the switches at this layer, they are configuring VLAN, also allowing them towards top of the rack switches, right? And that's how it works. Nothing else is there. Does it answer your question?
Yes, I got your point. And one question that the port channel and ether channel is same or different thing?
It's the same. It's the same. Some people say port channel. Some say some. So it's a multi-chassis. Sometimes design could be different also. It is one of the example. It could be something like that also. And it could be in stack also, like that. Not necessarily this design, but concept remains same.
Okay.
Yeah, and then individual port channels from top of the rack switches is possible, right? So individual means rather than MC. Right now you are saying multiple devices. This kind of setup. But again, concept remains same. They need to allow.
Okay, got it.
These could be in stack, logically one, and this could be the different independent entities. Then there is a port channel here, right? So there could be multiple scenarios. Maybe L3 interface from here to here. The class architecture, right? EBPN something, but top of the rack will more or less remain same.
Indra, I'll be back in 5 minutes. Is it okay?
Yeah, fine. I would like you to have here, but by that time I am asking questions taking questions. So Pranay, this is how it is. Hope it is going to help, right?
Yes, I got this point.
Yeah. So on network level, they do nothing but create some VLANs and allow on the trunk, so that end-to-end allow VLAN 10 is allowed. And they configure L3 interfaces properly, advertise that L3 interface into routing protocol, so that subnet gets advertised to the wider customer network.
Okay.
All right. So I'll go. So I think Pranay is good now. Avay, Amit, Jivendra, good. Saran, any
Yeah,
question? Yeah.
no questions. Like actually, as I said, I'm new to this VMware, so I had a bit challenging in understanding. So I'll go back and I'll try to read and see because it didn't go to it. I couldn't get much, so I'll try. I'll try one more time. Yeah.
Uh, uh, you know why you are not getting it? What is there?
Uh,
I
no, I
want to.
something something I lost in between, so
Yeah.
I
See,
couldn't. Yeah,
what I'm saying is.
yeah, on the server part and the VM part, which is this vNIC and um, those kind of that PNIC 2. So there I lost it. I couldn't connect myself. I was
Okay.
I was trying to
Okay.
understand and I lost it.
All right. No problem. So this is your. So when you do, what you do is.
So Indra, I'll be back in 5 minutes now.
Yeah.
Okay.
No problem. No problem. So here what you do is you have a big ESXi host, right?
Hmm.
You config. So what I told you that you create virtual machines inside this host, right? Virtual machines. This is what the hypervisor do. You understand that much? Because you will not understand it by reading anywhere, and I can tell you that
Okay.
it will be difficult for you. It will take a lot of time and understanding.
Okay.
So this is big box I have created for ESXi, just a bare metal server, right?
Okay.
And
Okay.
you also create virtual machines inside that host. Don't
Okay.
you? You do, right?
Hmm.
So how you create what? I'll come to that later. So hypervisor means you can create multiple virtual machines inside a physical server. That you agree?
Correct. Yeah.
Right. Now these physical servers need network connectivity.
Mm-hmm.
Do they need or not?
Yeah, they need.
So a virtual switch is also created. Virtual machines, so virtual switch. Agree?
Virtual switch will be created in that same ESX host. I mean,
Yeah,
same server.
same server. Yeah.
Okay.
Now these will be connected. You can manually connect them. These machines.
Mm-hmm.
You connect these machines to the virtual switch created here. How
Mm-hmm.
it is created, I'll come to that later. But I'm giving you how it works. Now you have every physical switch has server has physical uplinks, right?
Mm.
Right?
Mm, yeah.
PNIC we call them.
Mm.
Let's say this server has two PNICs.
Phoenix is nothing but the physical servers, right? I mean, physical ports.
Yes, physical ports
Okay.
that come with the box, right?
Okay.
And this is the only way you can go outside of ESXi host.
Correct.
Understand?
Yeah.
This is your switch,
Mm. A normal
right?
switch.
Normal switch uplink.
Yeah.
You give port a connectivity, right? We do
Yeah.
it for years. We have been doing it,
Yeah.
right? And this PNIC, you say, okay, you connect this PNIC also,
Mm.
right? And you talk to your compute people. They say we are going to create all these virtual machines. They will be placed in different VLAN, VLAN 10, 20, right?
Mm.
30, right? And this is your vSwitch.
Yeah.
And these PNICs are mapped to this one. Mapped to this one, right? Now
Mm.
this is configured with IP address, and this interface is called vNIC. Okay.
Mm-hmm.
From the vCenter, you apply this vNIC. So what you do, this VLAN 10 machine on VLAN 10 will use this vSwitch to get out of ESXi host. Or if this VLAN 10, there is another VLAN machine on VLAN 10 here only in the same ESXi host, then it will internally switch through the vSwitch. It does not go out of the ESXi host, right?
Mm-hmm.
So what happens is this vSwitch, virtual machine on VLAN 10 need to go outside. So it will say, okay, this is logically mapped to this one. This is called BMNIC
Mm.
in language in ESXi language. BMNIC. No, keep noting down what you are not understanding. Then ask all of them together.
Yeah. Yeah. I'm getting.
Note down in case
Yeah.
you are not whatever thought coming in your brain. Just note down. BNIC. What is the use if you are not learning, right? So VMNIC 0, right? So what happens is this virtual machine on VLAN 10 need to talk to default gateway. When a machine talks to default gateway means it has to go outside of its subnet. You understand from a networking point of view, right?
Yes.
From
Yes.
from networking standpoint, a
Yeah.
machine talks to default gateway only when the packet from a default machine goes to default gateway only when it has to cross the subnet it is sitting on.
Yeah.
Right.
Mm.
So in that, even in let's say it is even let's say you might have another ESXi host similar, right? Similar ESXi host configured similarly, right
Mm-hmm.
here, and virtual machine are sitting here also. In that case also it has to go up outside of the it's the ESXi host in the same VLAN also, right?
Mm-hmm. Yeah.
So it will say, okay, this should be trunk with VLAN 10.
Mm.
This should be trunk. This should be trunk. This should be trunk. If it is connecting to, now it's the top of the rack switch,
Mm.
right? It's the middle of the rack, top of the rack, or whatever you call it, bottom of the rack. It's people call it top of the rack. Sometimes it is placed in middle of the rack. People still say it's top of the rack. Anyway, it doesn't matter. So it's now L3 switch. I'm giving you a networking background from networking background. So I would not go deeper. I'm giving high level. This is L3 gateway configured here, right?
Mm.
You know that, right?
Mm.
So up to L3 gateway you trunk, right? Or normally in legacy network, right?
Mm.
Top of the rack, from host to top of the rack trunk, from top to L3 trunk. From
Yeah.
L3 it goes into the routing domain.
Correct.
Yeah?
Correct.
So it can go anywhere because of routing. So this vNIC, this virtual machine is connected to this. This is how it works.
Switch. Yeah. Yeah.
Yeah, and you can have multiple vSwitches.
Mm-hmm.
Now this much you understand?
Yeah, I got it.
So okay, keep it there.
Mm.
Keep your hold your breath there. 1 second. New slide. I'm coming to how it all starts. How it? I think from tomorrow onwards, rather than coming in the end, I will stop and ask questions in between, so that I don't need to repeat. So, so when you now how it all starts, you have a server, hardware server, right? you install, what you do? You install the esxi. That's a
Hmm.
hypervisor, right?
Yeah.
And make sure you understand that, man. One
Correct.
sec. Guys, rest of the guys, people, please bear with us. It will be revision for you, for sure. And so what you do? You buy a server, right? What you do? You install ESXi on that host.
Yeah.
Agree?
Yeah.
When you install is ESXi, during installation of vSwitch, 0 gets created, right? Let's create 0, vSwitch 0. This is vSwitch 0. And what happens? And one of the uplink could be 10, 20, depending on server, maybe 4, right? One of the physical uplinks, physical links, physical ports, let's say, physical ports of the server gets mapped to vSwitch 0, right? Now let me make uplink, let's take only 2 interfaces right now. So far good? Hello, you
Yes.
there?
Yes. Yes. In there, I was on mute. Yes. Yes.
This is
Please go
port
ahead.
number, this is port 1,
Mm-hmm.
or PNIC, you can say as per your convenience. Port 2, right?
Hmm.
Agree? What
Yeah.
I'm saying, when you install vSwitch gets created, and this vSwitch needs to connect to outside world. So what happens is one of the uplink physical port gets mapped automatically. Agree so far?
Yeah. Yeah.
Also, during installation, you give management you give management IP to the ESXi host, right?
Mm-hmm.
You give it when you install it,
Yeah. Okay.
right? You should understand that you are not installing, so take it, somebody installing it, you know it, right? This
Mm-hmm.
interface is nothing but a management interface on the vSwitch,
Mm-hmm.
right? Let's
Mm-hmm.
say this management interface is 10 10 dot 10 dot 10 dot. You give it IP address, you give it default gateway, right? During the installation, you do that. You give it a subnet mask, right? Obviously, you need to give subnet mask, right? Default gateway, subnet mask. These things you give to this interface, and a VLAN number also. Otherwise, it will be VLAN 0, default VLAN. VLAN number 10, let's say, during installation. Now, once the installation is over, you have already allowed VLAN 10 here, as part of discussion and all with the compute team, top of the rack, right? So what happens is you have already port, and there is connectivity on top of the rack, and this you have allowed VLAN 10, right? So far good, Saran?
Yeah. Yeah. Yeah.
You are following it all, right?
Yeah. Correct. Correct. Please go ahead.
Please do let me know. I want to make sure that you understand it. Otherwise, it will be difficult for you to
Yeah.
chase down an SX piece. So vSwitch 0 is here, right? And I'm not talking about the other uplinks right now. I can add it later. I'm talking about the default situation that arises after installation. You have vSwitch ready. On
Mm-hmm.
that vSwitch, you have a management interface ready. It has a
Mm-hmm.
default gateway, default IP address you have given, default gateway you have configured, you have given VLAN. During installation, you do that. Once it has this IP assigned, which means this ESXi host is reachable from outside. Agree?
Yeah.
You can ping it, right?
Mm-hmm.
Right? Once you can also, what you do, you have a vCenter here. You manage everything from vCenter. Now you on the vCenter can also access this management interface, right?
Yeah.
So you add this host in the vCenter.
Mm-hmm.
You add this host in the vCenter. Once this is added in the vCenter, from vCenter you can see vSwitch everything, and the uplink port also you can see everything. You can see. You go to vCenter and connect another port to it because you need high availability, right?
Mm-hmm.
Now either you make it port channel because esxi host servers are supporting LACP, or you make it active depending on discussions. Both will work. Now you create virtual machines from the vCenter, right? Here you are creating virtual machines from the vCenter, right?
Yeah.
And when you create virtual machines from the vCenter, you tell this, you also configure port group from the virtual center. You say, okay, this virtual machine will, you create port group, you create virtual machines independently, and then you apply that port group and you create that port group on the vSwitch, right? I have created a port group on vSwitch here on the vCenter. Port group 10 means, port group 10 means it is VLAN 10, and you apply that port group to the vSwitch. So this is how you connect from the vCenter. It's connected now, right?
Yeah.
And port group 10 means it is VLAN 10, and this becomes a part of VLAN 10. Let's make a VLAN 20, for example. Management interface was on VLAN 20 10. You can keep your virtual machines on the management VLAN also. It's no one going to stop it technically, right? Design wise, I don't recommend, right? So port 20, port group 20 you create on the vCenter, and you create a virtual machine from the vCenter on the esxi host, connect port group, apply port group 20 to virtual machine. Once it is applied, it is trunk already, top of the rack switch, up to top of the rack switch, and get wherever it wants to go. Agree?
Yeah.
Understood the concept?
Yes.
Now we had a discussion. Now we have different kind of interfaces. One is port group that connects to VLAN, the virtual machines. This is normal port group, vNIC. We have a uplink we call VMNIC.
VMNIC.
VMNIC. This is VMNIC.
Okay.
This is called VMNIC, right? And now we also discussed this interface is management interface, right? Initially, kernel interface. They are also called kernel interface. This is special interface. Now, this we are also going to create vMotion interface. Means this virtual machine, let's say this system itself is going down. I need to migrate this to another host that I told you, right? You can vMotion.
Correct.
This vMotion interface, let me put it in along the color. This interface will be mapped to this uplink, these uplinks. This is also like this is mapped. It will use one of them, active, or port channel, active standby. You can put them active standby, active, port channel, and all that. Correct? This interface is again vMotion interface, right? So when you want to move this virtual machine to another host, you can use the vMotion interface. It will use automatically vMotion interface. This is why vMotion is required. It will have IP address. It will be part of VLAN 30, 40 something, right? And this vMotion interface you configure from the vCenter again. Any gap here?
No, in there.
No gap?
Yeah.
So it is one story of one vSwitch. So how many vSwitches you can create? Now questioning. You can create multiple, multiple. I'm taking it off now, right? Just for I need more space. So these boxes you are seeing on the vSwitch, small circles. They are management. This is vMotion interface. This is management interface. Management interface is coming by default with vSwitch, and this interface you are creating, from the vCenter. It does not come automatically, right? That's what I know from what I did my CCI data center. This is a course of CCI data center, by the way. Anyone who has done CCI data center knows it already. So now coming to vSwitch 0, this is virtual machine, right? And this is your management vMotion interface. This is management interface. This is your vSwitch. Now, how many vSwitches you can have? That's another question, right? We can have multiple, maybe 100, 200, but you should have uplinks also. One uplink is mapped to one vSwitch only. So you have two uplinks, you can have only
In
two
the
vSwitch.
maximum number of 127.
Okay, thanks. 127 vSwitch you can create, but you should have 127 uplink also. Otherwise, there is no use. Maybe some usage could be there. I'm not saying there could not be use cases. In Nutanix, there is use case, by the way, right? Where without uplinks also we are using vSwitch. So there could be use cases where very rare. Without uplink, having vSwitch does not serve any purpose. Guys, got it? So this port 1 cannot be shared across switches. It will be one-to-one mapping. One uplink will be mapped to only one vSwitch, not two vSwitches or three vSwitches. Yes? And now you can say, I'll use vSwitch for only management or vMotion, and for any workload will go to vSwitch 1. Any virtual machine you want to connect, you will connect to vSwitch 1. Right? You will connect here. Right? So this vSwitch 0 will serve for management connectivity and vMotion. vMotion means this virtual machine need to go to another host. Tomorrow, let's say you do maintenance on this particular esxi host, you want to evacuate all the virtual machines from this esxi host to another esxi host. What you will do, you will vMotion them. From vCenter, you right click, and if there is option migrate, it will give you all the hosts where you want to migrate. So you click on that, it gets migrated. But when a migration happens, what interface it takes? It takes the management vMotion interface. This interface, this is system interface, right? This will take this interface to go for vMotion. But if somebody want to ping it, it will take this path. Somebody want some application. Let's say this is web server. Somebody users are coming from outside will use this path, data path. For vMotion, it will use this. This is internal communication, logical. Logically it gets mapped here. Don't go that far. You don't need to. You should understand concept. That's it. Yeah. Yes, certainly it helps.
Yeah, it helped.
This vSwitch you create not from inside. You create from from here.
vCenter, yeah.
Yeah, everything is done from vCenter. Yeah.
So under this vSwitch, if we have a different VLANs, the communication will still go out of the server, or it will happen internal only?
Sorry, ask again.
I mean, in the vSwitch 1, we have one VLAN 10, assume. If the same switch, we have VLAN 10 or different VLANs, that the communication will happen only between vSwitch and other things, or it will go out of the ESX host, like to the out of the server and then come back?
So you're saying in VLAN 10 and 22, they want to talk to each other, so how it will happen?
Mm-hmm.
This is what you're saying?
Yeah.
They are in different VLANs, right? They need to go to default gateway. Concept does not change.
Okay.
If they are on the same VLAN, let's say it's a VLAN 10, then it does not need to go out.
Okay, fine.
This is just a V. Remove VR, it's a switch only.
Okay.
Okay. It's a virtual, in the virtual hypervisor we are using to create it, call it virtual. Otherwise, functions are same. Okay. You are giving uplink. Even you connect to any switch today, physical switch, you give it uplink, downlink, everything you do, right?
Yeah.
You provision uplinks. You say, okay, 40 to port number till port number 92 in a stack. I'll give to my host facing. Uplink ports are 40 gig each. I'll give for uplinks to connect. Same way. There's no difference.
So Inder, I have again. I will repeat my same question. Okay, just to reconfirm, because now we have drawn this same scenario. If suppose my web this web application also needs to have a kernel port, which is for suppose management. Okay, because this VLAN 10 is for the data traffic. Okay, now suppose if I have a requirement of having a management of the web, and in this scenario, if my kernel port is binded to switch 0, so how the traffic will move from the I mean the kernel traffic will move from web to the vSwitch 0 to reach out to its destination.
Okay, I got your confusion. The thing is, see, This management interface, this one, is just to manage the hypervisor, nothing else, not the web server. Nothing, no relation with the web server, virtual machines. It is just managing your hypervisor. You can create virtual machines, you can create web servers, you can do migration. You can right click. Your vCenter can get to this esxi host through the management interface. So just from management point of view, web server might have a heartbeat interface, or maybe some server needs a management interface also dedicatedly. Possible, right? That way, it will act like this. Let's say some server. I don't know, some server.
So those management traffic will be treated as a data traffic.
Yes, it will have one more VNIC, maybe VLAN 30 here, right? You can have multiple VNICs.
You mean to say so just for my understanding, we used to have a ILO in the bare metal servers. So the ILOs could be considered as the kernel in this case, so that we could manage the hypervisors
Yeah,
as well
ILO
as
is
the
different. ILO has no relation with the hypervisor. ILO will
yeah,
be on the
I
vCenter.
agree. But
Yeah.
just to relate, so the kernels are going to be for specifically for accessing your hypervisor resources as well as your hardware resources.
Yeah. Just vCenter is accessing the controlling this host through the management interface.
Got the point. Thank
That's
you.
the only role. So, any question?
Is
Yeah.
there one
Yes.
question?
Yes. Go ahead.
Let's say we have a web server connected to switch one as you have drawn here, right? An user who is in branch office will come all the way from the network WAN to our TOR and hit that server. We are hosting something and user want to access this. Now, is it possible the web server needs to communicate with their database or web whatever, which is not allowed for the other people as per our designing in data centers? So if the database server is connected to vSwitch 0, then I mean, how web server will fetch those information? Is it possible, or this type of scenario?
I'm still trying to think.
So Vishal, so that is a east-west traffic. Okay, so in that case, it is going. Obviously, it will reach to its own gateways, and the routing will happen from there to reach out
Right.
to
So,
reach out to the
means
database.
web server has to go to the top of the rack to the default
Yes.
gateway and then come back.
Yes.
So now,
If it is in different VLAN,
So
if
you are
your
saying,
database is in different VLAN.
if you yeah, please continue. In case you need explanation, I can draw and explain.
no, go to that previous.
That diagram is good.
No, not this one. This one.
This
Yes.
one. Now,
Yeah. Now, let's say, Abhay, it is going to top of the rack and coming back. If it is in different
VLAN, yes.
Right. Now, let's say if it is in same VLAN, but these two virtual switch are not connected to each other. In that case, also it is going, or we have a option that we can connect two virtual switch as well in esxi.
Yeah. In that case, it will go up. Let's say you have this VLAN. That's what you're saying, right? You have another vSwitch here, right? And port group is there, right? Like that. This is what you're saying, right? To virtual machines are connected.
This is our database server, let's say, under vSwitch 0.
Which VLAN? Which VLAN?
VLAN 10, which we having web server.
It will go up in no other way.
So the question from Vishal was that there is no mechanism of interconnecting the vSwitch 0 and vSwitch 1.
No.
Yeah. So it has to go upside then.
Yeah. It has to go upside. It cannot happen that way, yeah.
For same VLAN also.
Yeah, for same VLAN. Until if it is on the same switch, then it's internal. If it is on the different switch, then no, it will not happen through the same.
So it means that Vishal, the broadcast domain, first of all, the uplink of the vSwitch 1 will reach out to the TOR. TOR will again have the same broadcast domain. It will again return back via the port channel or whatever interface, trunk interface. And again, it will come back to the vSwitch 0. So it is going to be a part of same broadcast domain, how we do in the case of trunking in the network infrastructure.
Exception is only for management and special system and kernel interfaces. That's it, for no one else.
Mm.
Okay.
Yeah. All right. Great, guys. So let's move. Let me move forward. If you do not have any questions, I need to ask one by one. Saran, you are good.
Yeah, I'm good, Inter. Thanks.
Yeah, please
Thanks for.
just do some introspection and if there are some gaps, put some efforts and come back with
Sure.
your questions next class.
Yeah.
I would be able to answer all that.
Yeah.
So Jivendra, Amit, Pranay is good, I know. Sonu, Sonu, please, have you understood all that I explained? Sonu, you there? Hello? No. Vikrant, you have any questions if you have not understood?
No, Indra, it's okay.
Now, I can draw again. I mean, others can go for the day.
No, no. Actually, you know what? As far as like twice, it's good. But I will also study, and if there will something, I will come up next week for sure.
Yeah, I'll tweak my study now. Rather
Yeah,
than
but
asking,
but in there one thing,
uh,
can you please guide us some document where we can have a like study of that thing that you make us understand, try to make us understand. Is there
yeah,
some document?
always tons of documents are on the Google. I cannot suggest one. You ask me today also if I need to clarify my doubts, I go to Google and uh, look for best resource. I'll
Okay,
I'll
thanks.
try one, two, three until I am convinced. So that's how I do. You do that way, you will get tons of resources. But the way I have taught you, you can develop further into it. You can go deep. It's not the but from networking point of view, if you want to widen your skills, this is more than enough for designing, troubleshooting, implementation. More than enough.
Okay,
This kind of knowledge. If you want to go product specific, you go deeper and understand a hypervisor programming level. I'm not going that far, and no intention also in future.
okay,
So,
thanks.
so this is understood to you. This is concept. This
Yes,
why I'm saying is this is very important for you to move ahead with NSX learning. Otherwise, NSX will go over your head if you do not get it. This is basic to NSX. Yeah.
yes, yes.
So this is simple concept, guys. You have ESXi host, means you have any host that has ESXi installed called ESXi host, right? Once you install ESXi means you just virtualize it, which means what? You can create multiple virtual machines. When you create multiple virtual machines, you need a switch to connect them, which is vSwitch. The vSwitch needs to go outside. Then you have a physical ports. Those physical ports are mapped to vSwitch, right? And then you have some special interfaces, vMotion interface or kernel interfaces of vMotion or kernel interface. A management interface, also called kernel interface. But when you are installing ESXi on a host, it asks for your IP address management management interface. It asks for VLAN ID also. You can change that. It asks for default gateway, data servers, everything you configure. Once the ESXi host is configured fully, you have connected to your server to the correct physical ports on the top of the rack switch. Your ESXi host will be accessible, right? And once it is accessible, which means it is accessible from vCenter also, right? And on the vCenter, you can now manage the ESXi host. You can create vSwitches, you can give more uplinks to the vSwitch, you can create virtual servers, you can do migration from one ESXi host to the other ESXi host. You can create, you can give more uplinks or port groups. You can create port groups, nothing but these are the port groups you create to connect to your virtual servers.
In there, I have my final question. If suppose you take the Web02 machine, the VM, okay,
Mhm.
and suppose it requires a vMotion also. So in that case, this vSwitch one needs to have a kernel interface on this vSwitch, right? And it
Yeah, yeah.
has to be mapped to the port this second one.
No. So see the VCs, as I said, like VC0 has this red one. It will use this. Maybe it is this Web2 is connected to VC number 20. Doesn't matter. But
Okay,
it
so
will
it
use
will
this.
internally that vMotion traffic has to go via this vSwitch 0 only.
Yes.
And this kernel interface has to be mapped manually to any of the uplinks.
Yeah, it depends. The uplinks you don't need to map manually. What happens? Let's say you have two uplinks here, right? Let's say, right? So there are two ways. One is lag P, between this is what you are asking, right?
Yes.
You do uplink. If there is one link, obviously one link will be used. Question arises when you have more than one link, right? That's why I created another link for you. So what happens? Either you make it lag P, then lag P algorithm will take care. One. Second,
That is fine. That is fine. So it means that the kernel interface should not be a kind of a mandatory to have on the local vSwitch. It can be on any of the vSwitch. It will automatically cater those interfaces, even though the machine is on the different vSwitch.
correct statement.
Yeah,
Agree.
fine, fine.
Not necessarily vSwitch 0. That is also true. Any vSwitch you can configure.
And also, you will take us through the DVS now, because this is a standard switch. I hardly see it is being used in any of the scenarios nowadays.
No,
It is
no,
very less
yeah,
used.
our concept is remain same. DBS is
That concept will remain same.
I'll come to DBS.
Okay.
Inside ESXi host, it will never change. It will remain same. It's
That
just
is
a
fine.
central management plane. DBS is combining these switches together, and you configure port on DBS. It will be propagated to all the ESXi hosts. That's the only difference. But inside ESXi host, situation remains same.
Uh,
Fine,
Inside
fine.
ESXi host. Inside ESXi host.
But again, I will in there I will request that
Yeah,
maybe
I'll come
next
to that.
session just take us through the DVS also.
Yeah, of course. That is part of the course. I
Yeah.
have to make sure that. Yeah.
Okay. Thank you.
DVS here. Of course, you will see your DVS. You see already here. Core group. In the course, you will see DVS. You see the distributor virtual switch. I have not yet even started. Distributed. How it just started. If somebody was saying something, please go ahead. Because Vishal.
Indra, how many nicks we can create in a VM?
Maybe 256 or maybe more. I don't know. I don't have the exact number. If given here, I don't know. Maybe here is.
Okay.
Yeah, it's a huge number, by the way. Not here. So maybe here. Mm. Okay, it's a number. It's a huge number, I believe. I don't know number. Yeah. So now let me go to another guy before we wrap it up. And Jivendra is good, Pranay is good, Sri, Sonu. Sonu, you are not there, right? Hello. That's not good, man. You are missing out on something very important.
He's
Uh,
having some issue with his mic, so he cannot speak.
yeah. Okay. Let me see what he's saying. Okay. Anyway, I'll cover for him in case he's not good. So I have to breathe. So in the beginning
He
of
said that, Indra, he said that he's good for now.
okay,
Problem in mic.
okay. So we have to bring everyone to the speed, and this might cause delay for some other people who are getting it fast, and some may be strong on one area and some may be strong on another area. So we have to accommodate for each other. That's all I need from you guys. All right. From here on, we are closing for the day. It's already 10:39 and 2 hours done. And so we will start from here again. Kernel
So
interface.
in the before you wrap up, one thing,
Yeah.
as you mentioned yesterday that you are going to give some like routing switching classes in this week. So can you please send
Friday.
an
Friday. Who is speaking?
Vikrant?
So yes, Vikrant, I am going to send a meeting ID on Friday or something. Be flexible. Friday or Friday.
But if
Or
possible, can you please inform us like in like 4 to 5 hours in advance so that if we are
yeah,
somewhere,
I'll do that. Let's
thank.
do that today evening if you guys have time. Maybe you know
But
around 10 p.m. 10 to 11 p.m. if you are good.
I'm good. But for the persons you want to main specific
Yeah, yeah,
for
yeah,
them.
Yeah,
yeah.
Indra, I'm also fine with that.
Yeah, one class today evening and one more class. That should be okay. I'll take you through the basics you need for NSX, not in a greater details. So yeah, that's what the plan is. Okay, I'll send the invite for 11 p.m. today. Yeah.
Thanks.
Okay.
All right. Any questions before we close it? Any question, concern, comments, suggestions?
No, it's good explanation you gave for everything.
Yeah,
So
you
it's
guys
going
call me
good
Inder
way.
also. So my name is basically Inder, guys, and I have changed my name officially also. It's a Inder, and in documents also it's a Inder. So it's now some
Earlier it was different something.
no Indra. Some people
Okay, okay.
officially it used to be Indra, but in my current company also people know me as Inder. So it's up to you. I mean, it's officially changed also documents also. It's a Inder only. All right, guys. So thank you. Thanks for joining.
Thanks, Inder.
We'll meet. On what? Let me see.
Today
27th,
evening as well.
Saturday 2nd. All right, guys. Thank you. Bye bye.
Thanks, Inder.
Okay,
Bye.
thank you, man.
Bye. Thanks.